Now let's talk about trig functions and the chain rule. So we know the derivative of sine and the derivative of cosine. And all we're going to do is take those derivatives in the same way. I leave the inside the same. So whatever was inside before will be inside again, and then I multiply by the derivative outside. So that outside is different than what the inside was. So depending on what order you're doing these notes in, you might actually not have seen these second set of derivatives. We will use the rules today. Just know that in 2.6 is where you will actually see them worked out. So derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. So a couple of things here. Notice the cos are negative. So all the cos, so cosine, cotangent, cosecant, their derivatives are all negative. You can remember that. And I also remember these in pairs. So secant squared, cosecant squared, secant tangent, cosecant cotangent. And so that kind of helps me remember. Whatever you need to do to memorize those, you should start working on that. Those are, again, on your Stuff You Must Know cold sheet. So now let's actually use those rules. So we're going to find the derivative in example 4 of y equals sine of 2x. Now I don't actually see parentheses here, so you might want to add them in just to really pinpoint what your inside and your outside is. So my outside part is sine. My inside part is 2x. And so when I take the derivative, dy dx or y prime, I take the derivative of the outside, which is cosine of 2x, and then I multiply by the derivative of the inside, which is 2. I can leave it like that. Usually we'll put the constant in front though. It's the same idea for b. We have y equals cosine of 3x minus 1. It's a little easier to see my outside and my inside because there are already parentheses here. So for my derivative, y prime, I take the derivative of cosine, that's negative sine, of the inside, 3x minus 1, leave that alone, then times the derivative of the inside, which is 3. Again, I usually just rewrite that with the constant in front. So if you want to put the constant in front, once you get used to it, you can just do that step automatically. For the last one, we have y equals secant of 4x. So notice the 4x would be in parentheses there. So when you're looking at that derivative, secant of u, so my 4x there is the u. Notice that when I take the derivative, it's secant of u, tangent of u. So those both have the u inside the function. So we'll often say the derivative of secant is secant tangent, but it's actually secant x, tangent x. They each have their own variable or expression. And then outside of that is where I take the derivative. So you'll have to be careful on this one. So y prime is secant of 4x, tangent of 4x. So secant tangent, but I leave that inside part the same. And then I multiply by the derivative of the inside. The derivative of 4x is just 4. So again, you'll see, we'll just rewrite it as 4 secant of 4x times tangent of 4x. So sometimes you'll have to use the chain rule more than once. So sometimes you'll have a function within a function within a function. For example, in A, we have y equals sine to the 4th of 3x. This might not look like a three-part composition, but it actually is. So remember with trig functions like this with exponents, you want to rewrite them first. This really means sine of 3x all to the 4th power. So when I'm taking that derivative, I essentially am just peeling back one layer at a time. And you'll often hear me call these peanut M&M problems. So we've got the candy shell, we've got the chocolate, and then we've got the peanut in the middle. So I'm first going to look at the something to the 4x, or sorry, something to the 4th. So the derivative of that would be 4 something to the 3rd. It's just that that something is still the sine of 3x. So I leave that part the same. Then I'm going to go to the next part. The sine is my next layer. So my derivative of sine is cosine. And then I still leave the inside alone, 3x. And then finally, I multiply by the derivative of the 3x, which is 3. As always, I can leave my answer like this, but you'll usually see it simplified or rewritten kind of in the similar way that the problem was written. So the 4 times 3 is 12. Sine to the third of 3x times cosine of 3x. You'll see it with or without parentheses. I think it looks a little nicer with parentheses, but it does require a little bit more writing. Okay, part B, we have y equals square root of cosine of x over 2. So always think about, is there a way to rewrite this before I take the derivative so I can see things more clearly? There is in this case. We want to do cosine of x over 2, or 1/2 x is an easier way to think about that, to the 1/2 power. Remember, radicals are to the 1/2 power. So now when I take my derivative, I have something to the 1/2 power. So that derivative is 1/2 something to the negative 1/2. I leave the inside the same. Now on to my next layer, which is cosine. So the derivative of cosine is negative sine. So I'm going to use parentheses here just to keep track of my negatives. I leave the inside the same. And then I multiply by the derivative of the inside, which is 1/2. I'm going to simplify now. Notice I have a negative exponent here. That's going to go in the denominator. This negative sign of 1/2 x is going to go in the numerator. I have 1/2 times 1/2. That will give me a 4 in the denominator. So in the numerator, I have negative sine of 1/2 x. In the denominator, I have 4 square root of cosine of 1/2 x. On part C, I want you to pause and see if you can rewrite this in the proper form before we take the derivative. So go ahead and pause now and try that out. Okay, so what you should have gotten is this is sine of 3/2 x, or 3x over 2, but I like the constant in front, all to the 2/3 power. So make sure you write it like that first before you take your derivative. So my derivative, I'm taking the derivative of something to the 2/3 first. 2/3 something, and then my new exponent would be negative 1/3. Subtract 1. Leave the inside the same. Times the derivative of the inside. The derivative of sine is cosine. Still leave the inside the same on that cosine. And then times the derivative of the 3/2 x, which is 3/2. This is an okay way to leave your answer, and even on your Delta Math assignment, you can leave it like that. We're going to go ahead and simplify it though. 2/3 times 3/2 is just 1. They would cancel out. And so then I'm going to have cosine of 3/2 x all over the cube root of sine of 3/2 x. So it's negative 1/3, so cube root in the denominator. So at this point, you really know the big 3 rules of differentiation. So you know product rule, quotient rule, and chain rule. And now what you're going to have to do is decide which rules can be used when. Sometimes you'll need more than one. So in 6a, let's think about what rules would I need to use. So I have to decide, is there a product involved? Is there a quotient involved? And is there a function times a function inside of another function? It might help you to rewrite first. So we have 5x times square root of x plus 3. Whenever I see a radical, I want to rewrite it as something to the fraction power. So in this case, 1/2. And so I can see my two parts here. I have 5x and I have x plus 3 to the 1/2. Those two are being multiplied together. So I know I'm going to use the product rule. But I also notice that this radical has a function inside of another function. So x plus 3 inside of to the 1/2. So that means I'm going to also have to use the chain rule. If you're not sure which one to use first, try to decide, does this look like the product of two things, or does it look like something inside of something else? And overall, it looks like two things being multiplied together. So that means I'm going to use product rule first, and I'll just have to use chain rule when I take the derivative of this second part. So f prime of x, I'm going to take the derivative of 5x first. That's 5 times x plus 3 to the 1/2. Leave the second part the same. Plus the first part, 5x, times the derivative of the second part. And this is where I'm going to use chain rule. 1/2 times x plus 3 to the negative 1/2 times the derivative of the inside. The derivative of x plus 3 is just 1. Now, this is an okay way to leave your answer, and this is what it will look like on Delta Math. You can leave it there. However, we're going to go ahead and simplify since we're working it out together. So that usually means rewriting in radical form. So we've got 5 square root of x plus 3 plus 5x over 2 square root of x plus 3. Now sometimes you might actually want to get a common denominator here and combine those. If you did, I would need to multiply this first term by the denominator of the second term, so times 2 square root of x plus 3, top and bottom. So that would give me 10 times the quantity x plus 3 plus 5x in the numerator all over 2 square root of x plus 3. So again, that was 5 times 2 is the 10, square root of x plus 3 times square root of x plus 3 is just x plus 3. I can simplify that now. 10x plus 30 plus 5x would be 15x plus 30 all over 2 radical x plus 3. So that's your nice simplified form. You don't have to worry about doing that unless it's multiple choice or unless you're asked to do that. For part B, we have g of x equals sine of 2x plus 1 over x minus 3. So I noticed my eyes kind of go right to this quotient, but I'm not going to use quotient rule first because what I noticed is that quotient is inside of something else. And so when I have a function inside of something else, that means I'm going to use chain rule. I will use quotient rule as well though. But since overall this looks like something inside of something else, my main rule is chain rule, and then I'll use quotient rule when I'm taking the derivative of the inside. So for my derivative, take the derivative of the outside first, cosine, leave the inside alone. And now I'm going to multiply by the derivative of that inside, 2x plus 1 over x minus 3. And that's where I use the quotient rule. So low, x minus 3, d high times 2 minus high, 2x plus 1, d low times 1, all over x minus 3 squared. Perfectly acceptable way to leave your answer. I'm going to go ahead and simplify this a little bit more. We have cosine of 2x plus 1 over x minus 3. Now, one important thing to note is that is attached to the cosine. You cannot combine it with any of these other things that we do. That is inside of the cosine. It will not let it go. We have times then 2x minus 6 minus 2x minus 1. Make sure you distribute that negative all over x minus 3 squared. A little bit more simplifying we can do cosine of 2x plus 1 over x minus 3 times the 2x's cancel here, and so I have negative 6 minus 1, negative 7 over x minus 3 squared. And that will be my final answer. For the last problem, we have h of x equals square root of 2x plus 5 over x minus 3. So overall this is a quotient, but within that we have a function that is inside another function. So this is 2x plus 5 to the 1/2 all over x minus 3. So I'm going to use the quotient rule first and then the chain rule within that. And again, that's because overall this looks like two things being divided. So for my derivative, I'm going to take low, which is x minus 3, d high, derivative of the top, 1/2 times 2x plus 5, so the negative 1/2, minus high, 2x plus 5 to the 1/2, d low times 1, all over the low squared. This is an okay way to leave your answer. We're going to simplify it together. Up here, I forgot to multiply by this too. The derivative of the inside here. So I wasn't doing a good job of the chain rule. So I had to multiply by the derivative of the inside. That 1/2 and the 2 actually do cancel each other out though. And so what I have is x minus 3 over square root of 2x plus 5 minus a square root of 2x plus 5. That's not in a denominator. That's just, that has an exponent of positive 1/2 all over x minus 3 squared. Now that doesn't look actually very pretty. We want to simplify it a little bit more. And so to do that, we're going to get rid of this complex fraction, the fraction within another fraction. And so what we can do is just multiply by this denominator, square root of 2x plus 5. But I need to do that in the numerator and the denominator, and I need to make sure I distribute when I do that. So I have to distribute this through. When I distribute it to the first term, the denominator cancels out with that square root of 2x plus 5. That's why we did this. So we have x minus 3 minus, when I multiply square root of 2x plus 5 times square root of 2x plus 5, that is just 2x plus 5, but I do have to put parentheses here, all over x minus 3 squared times square root of 2x plus 5. Don't try to expand that part. We'll leave that part factored. We can simplify just a little bit more. We have x minus 2x, that's negative x, and negative 3 minus 5, that's negative 8, all over x minus 3 squared times square root of 2x plus 5.